Hello, good morning students. Welcome back your chemistry class once again. So as you know that in the last video class we started your online class we started your unit that is state of matter, and in this unit will be topic is covered that is Boyle's law under your topic gases law. Okay, that is the first law is already covered in the online classes and video, that is your Boyle's law. So today will be discuss your second that is your Charles law. According to this law, when अ सिस्टम दैट इज टेक योर गैस, किसी भी सिस्टम में जो गैस कंटेन किया गया है उसमें हमारे पास क्या रहेगा, दैट इज प्रेशर इज योर कांस्टेंट एंड वॉल्यूम ऑफ गिवन ऑफ मास गैस, वॉल्यूम ऑफ ए गिवन मास ऑफ गैस दैट इज डायरेक्टली प्रोपोर्शनल टू अ temperature, and temperature is considered in terms of Kelvin. Okay, so this is the mathematical representations for you this law. Volume of given mass of gas is directly proportional to its temperature, that is considered in Kelvin, and the system of that is gas contained is your constant pressure. Okay, you can also be write in the second way, that is B by T is equal to constant and be a constant pressure. This is the mathematical representation of Charles law. Okay, when the condition your volume and temperature is changes, so you can also be write in the second way, V1 over T1 is equal to V2 over T2 at a constant pressure. This is the condition for when the your volume of a gas that is V1 is changed to V2 with a temperature of gas that is T1 as to change to with your T2. Okay, so by using of this formula you can be calculates the numerical values in case of in this fourth term have given your three terms, and the fourth one you can be calculated. Okay, so you can also be draw a graph between the pressure and temperature. Similarly, you can also be write this equation V is equal to K into T. Okay, and this is equal to slope of equation mx. Okay, so y-axis is your volume and x-axis is your temperature, and the slope of equation that is a straight line according to this. Okay, when the y is equal to mx, so here the slope of line equation that is a straight, and here m is your related with your slope, so slope of line is equal to that is k, and that is equal to m. Okay, they have already discussed in your Boyle's law when the slope of equation y is equal to mx. Okay student, this is about your Charles law. Okay, so students, next topic that is your Gay-Lussac's law. Okay, and be called as a that is also be known as a variation of pressure with temperature at a constant volume. Okay, this is a law will be given about the information in related to your article, that is variation between the pressure and temperature. That means ki that is a pressure of gas is directly proportional to temperature and with a constant volume. This is also given about the Gay-Lussac's law, that we also name as a variation of pressure. Okay, so again explain the statements. What is volume of the system, that is your constant. Okay, and second thing here, the pressure of given mass of gas, pressure of given mass of gas is directly proportional to its temperature, and temperature is considered in terms of Kelvin. Okay, this is about the Gay-Lussac's law. when the your system, मैंने आपको पहले भी बोला था गैस ऑफ स्टेट ऑफ मैटर हम स्टडी करेंगे for variable that is pressure, temperature, volume and number of moles of gases. Okay, so here volume of gas that is constant and pressure of the gas that is directly proportional to its temperature. Okay, and temperature is considered in terms of Kelvin. Okay, so this is the mathematical representations, or you can also be write that is P by T is equal to constant at constant volume. Okay, second thing, you can also be write in way for numerical values, P1 over T1 is equal to P2 over T2 at a constant volume. Okay, so by using this values formulas mathematical expression, you can also be calculate the any one value same in this pattern. Okay, and you can also be draw a graph that is also obtain a straight line. Here is pressure and here is your T, because this can also be write in terms of pressure is directly proportional to temperature. So here pressure is equal to Kt. So that is y and that is m and that is x. Y axis is your pressure and x axis is your temperature. So again that is slope of equation that is obtained in a straight line. Okay, so this is about Gay-Lucas law, and that we called as a variation of pressure with temperature at a constant volume. Okay, this is about two law. So students, next that is law, Avogadro law. You have already learned in the first unit about the Avogadro law. According to the statement of law that is given about the information कि equal volume of all gases under the same condition and temperature, okay, that is contain equal number of molecules. So here V is directly proportional to n number of molecules. Okay, so Avogadro law according to the statement कि equal volume of all gases under the similar condition of temperature and pressure, that is your similar या same condition of temperature and pressure, equal volume of gases that is equal to the number of molecules. जितना हमारे पास वॉल्यूम रहेगा ऑल गैसेस का, ठीक है, इक्वल वॉल्यूम होना चाहिए, अंडर सिमिलर टेम्परेचर और प्रेशर कंडीशन होना चाहिए. तो सभी गैसेस में कैसा रहेगा, वहाँ पे इक्वल नंबर ऑफ मॉलिक्यूल्स प्रेजेंट रहेंगे. दैट इज अकॉर्डिंग टू द एवोगैड्रो लॉ. सो दिस इज योर वॉल्यूम इज डायरेक्टली प्रोपोर्शनल टू द number of molecules. Okay, next is your that is explain about ki how to be write a molar volume under the different condition. Okay, that is your standard temperature pressure condition and it's your standard evident different and standard evident temperature and pressure condition. So here that is two type, that is your STP and second is your SATP. Okay, so this is your standard and A stands for ambient, sorry not evident, that is ambient temperature pressure condition. So all you know about the standard temperature pressure condition, that is your 0 degree Celsius of your temperature. Okay, pressure is your 1 atmospheric. Okay, pressure is your 1 atmospheric and volume is considered that is 22.4 liter, that is your standard temperature pressure condition. Okay, but in case of here pressure is considered in your 1 bar. Okay, so 1 bar your pressure, that is your volume be considered as a 22.7 liter mole inverse. Okay, so here that is under your pressure is 1 bar, so you consider a volume this, and here when the STP condition your pressure is term of atmospheric, so you can write you take a volume that is 22.4 liter. Okay, but that is a second condition, that is your standard evident temperature and pressure condition. इसमें हमारे पास जनरली क्या रहता है, here the some times of scientists we used for this condition, that is a little bit not a more than, इसको बहुत ही रेयरली में यूज़ किया जाता है फॉर साइंटिफिक वर्क्स के लिए. सो हियर द टेम्परेचर इज योर 298.15 Kelvin of temperature. Okay, pressure is your 1 bar of pressure, that is your pressure. Okay, and third one is your that is volume. So volume is considered that is a 24.789 liter mole inverse, that is your volume. So this is about your condition according to the SATP. Okay student, so this is about your condition in a different, okay, molar of volumes ki. Okay, next is your ideal gas equation. So student, ideal gas equation that is be the we called as a combined gas law. Basically ideal gas equation is derived by the using of three laws that is already learned, that is Boyle's law, Charles law and Avogadro law. All these laws is combined to make a equation that is be called as a ideal gas equation. So according to the Boyle's law, okay, according to the Boyle's law, okay, that is your pressure is inversely proportional to volume or volume is inversely proportional to pressure, you can also be right. Second, according to the Charles law, that is your volume is directly proportional to temperature at constant pressure. Okay, and here constant is your temperature. Second is your third one is your according to the Avogadro law. So here volume of gas is directly proportional to the number of molecules of gas. Okay, this is about the three law. First is according to Boyle's, that is volume is directly inversely proportional to pressure. Okay, according to Boyle's law. that is volume is inversely proportional to pressure, and you can also write pressure is inversely proportional to volume. According to the Charles law, volume is directly proportional to temperature, and Avogadro law, that is volume is directly proportional to number of moles of number of molecules of gas. Okay, so when you can combine all three these equation, that is volume is inversely proportional to pressure and directly proportional to temperature and directly proportional to number of molecules of the gas. So you can also be write in this way: V is equal to N1 by P T, okay, and the proportionality constant, that is your R. Okay, so this is in the way for right of this equation, that is PV is equal to nRT. Okay, this P is crossed by multiply this volume, so PV is equal to nRT. This is your ideal gas equation. PV is equal to nRT, and most of the time they have used in different areas. Okay, R is the molar gas constant. R is the molar gas constant. Okay students, this is about the ideal gas equation. Or when you can write in ideal gas equation for a 1 mole of gas, so you can just place the value for N is equal to 1 and PV is equal to RT. This ideal gas equation for you can write for 1 mole of a gas. Okay, and this gas equation be called as a equation of state. The ideal gas equation can be called as a equation of state. Okay, so students, next topic, that is your relation between molar mass and density of gas. This relation has also related with the ideal gas equation. So according to the this relationship between molar mass and density, what's the relationship? Okay, so you all know that number of moles is be calculated, that is given mass of any substance, and it's a molar mass, that is number of moles for calculation. This your N value, N is equal to mass of any given substance, that is according to division of a molar mass. So you can place this value N for this equation. PV is equal to nRT. PV is equal to N is your small n divided by capital MRT. Okay, so next step is what, that is P is equal to M over V and RT upon capital M. All you know that density is equal to mass upon volume. Okay, density upon mass upon volume. So here M over V, that is replaced with your D, that is density. Okay, so students, here when the substituting the value of N is equal to small m by capital M. Okay, so you can place a value and will be calculated for mass upon volume, that is equal to density. So here that is replaced with your small d and RT upon M. Okay, so after that the question is asking the relationship between the molar mass and density. Molar mass and density, the molar mass is capital M and density is your D. So this is the relation for calculation. Okay, so firstly we calculate for density of relation, that is a PM over RT. This is your first relation between the density and molar mass. And second one, that is the question is asking to calculate molar mass. So M is equal to D RT upon P. This is your second. So this is about the relation between the molar mass and density. This is for density and this is for a molar mass of relation. Okay student, so this is about the ideal gas equation. With you can also be ideal gas equation be relate with your it's a density. Okay, that's why this ideal gas equation is related to with a relationship between molar mass and density. Okay, sometime we question asking ki ideal gas equation in term of its density, so you can also be derive, you can also be explain about by this mathematical expression. Okay, so students, next topic, that is your Dalton law of partial pressure. Okay, this is a mathematical expression. Okay, according to the Dalton law, what about says that कि if two or more gases which do not react chemically, कोई भी दो gases हैं which do not react chemically and they are enclosed in a same vessel. Okay, so total pressure exerted by the gases mixture, that is the total pressure of the gas. Okay, total pressure of exerted by the this gases mixture is equal to the sum of all the partial pressure of each gas would be exerted when the present alone in the same vessel at a same temperature. Also you can be say that if two or more gases which do not react chemically and that are enclosed in a vessel, the total pressure is exerted by the gaseous mixture is equal to the sum of all the partial pressure of that each gas that is exerted and when present in the same vessel with its same temperature. ओके, दिस इज अबाउट्स योर डॉल्टन लॉ। मीन से दैट कि जो टोटल प्रेशर हमारे पास गैस का रहेगा, ठीक है, मिक्सचर का, दैट इज इक्वल टू द इंडिविजुअल पार्शियल प्रेशर ऑफ ईच गैस एंड दैट इज योर विद द सेम टेम्परेचर एंड अ सेम वेसल. So this is the mathematical expression. P is equal to, yeah, P total is equal to P1 plus P2 plus P3 plus P4 up to Pn. Okay, this is your Dalton partial pressure. Okay, so here the application of Dalton law of partial pressure you can be also calculated by, you can also be application this by Dalton law of partial pressure. So here is the application of Dalton law of partial pressure, that is indetermination of pressure of dry gas. By using law of partial pressure you can also be determine the pressure of a dry gas. So whenever a gas is collected over the water, कोई भी गैस है हमारे पास collect हो रही है over the water, that is your moist gas. Okay, that is your moist gas and it is saturated with water vapor which exerted their on pressure. सैचुरेटेड किसके साथ, वाटर वेपर्स के साथ, और वहाँ पे वो क्या बन रही है, एक प्रेशर क्रिएट कर रही है एंड दिस प्रेशर ड्यू टू वाटर वेपर्स इज कॉल्ड एक्वस टेंशन. So this is the mathematical expressions how to be calculates for the pressure of dry gas is equal to pressure of the moist gas. Firstly is your pressure of dry gas is equal to the pressure of moist gas minus to the aqueous tension at which temperature that is also be considered for a aqua tension. Okay, next is your in calculation of partial pressure. Okay, so in the second application how to calculate the partial pressure by using the Dalton law. If a mixture is non-reacting in a gas like your ABC, according to the statement of Dalton law says that if two or more mixture of gases that is be exerted, yeah, that is be collected in a same vessel, that is a non-reacting gases. So similarly in a mixture of non-reacting gases that is ABC, if each gas is considered to be ideal gas है हमारे पास, ठीक है, so when we applying the equation that is PV is equal to nRT. So for first pressure of the gas that is PA is equal to NA/RT upon B. Okay, NB NC. Okay, so according to the Dalton law of partial pressure that is P is equal to PA plus PV plus PV and plus PC. So you can also be take the common that is RT in all cases and here NA, NB and NC for a number of moles. Okay, so next is your PA divided by P, that is total. Okay, partial pressure of gas that is divided by total pressure is equal to Na, that is a mole fraction. So first moles that is divided by total sum of किसी भी एक कंपोनेंट्स का निकालना हो किसमें, टोटल में. So that is a mole fraction is equal to XA. So partial pressure of a gas A is equal to mole fraction of A into total pressure. That is the mathematical expression for calculation of a partial pressure. So this is your for first, and similarly for V and so on. The mixture of non-reacting gases you can calculate the partial pressure. This is your partial pressure of A is equal to mole fraction of A into total pressure. Okay student, so this is about the Dalton law of partial pressure and it gives the two application. First is your determination of pressure of dry gas and second one to calculate the partial pressure of a gas. Okay, so thank you and have a nice day students. I hope you understand about the topic.